Hey everyone, you've probably used ChatGPT to write essays, debug your code, generate content, or even ask random life questions. But have you ever stopped to think, how does it actually work? Today I'm going to show you exactly how ChatGPT works, step by step, no complicated code, just clean and simple visuals using Excalidraw. Let's go. So to understand how ChatGPT actually works, we have to understand these 5 processes. First process is tokenization. Second process is the transformer, and this is the process where the real magic happens. So we're going to understand in a bit detail about the transformer layer. Third layer is training on huge text data. Fourth layer is fine tuning with humans, and the fifth process is text generation. First, let's talk about how ChatGPT reads what you type. When you write a sentence like, I love artificial intelligence, ChatGPT doesn't just see this as words. It breaks down into something called tokens. Think of tokens like a small piece of text, sometimes whole words, sometimes just part of words. For example, word I in the sentence I love artificial intelligence can become token 70. Love can become token 260. Artificial can become token 780 and so on. So basically in the tokenization step, your sentence is converted into a list of numbers. Why? Again, because your AI models don't understand letters. They work better with numbers and patterns. Now comes the heart of the system, the transformer. So to understand about transformer, we will go through example. So let me give you a text. I love deep learning. So suppose you have a text, I love deep learning. Let me make this nice and big so that you can understand. So suppose we have a sentence, I love deep learning. So every word should become a token. So let's create a token for each of these words. Suppose I word is associated with a token 60. Similarly, let us make token for each other words in the sentence. 60, 80, 80 and then 90. And then probably let's make 100. So every word in a sentence I love deep learning has become a token. So after associating a word in a sentence into tokens, now the tokens go through a layer called embedding layer. So let me create a layer, and this layer is called embedding layer. So what happens in the embedding layer? So once your words are converted into tokens, these tokens are further converted into vectors. So let's convert into vectors. So vectors are just a numerical representation. So let me make a numerical representation of the token 60. Again, this 60 is a numerical representation, but again, to this the token is further converted into another numerical representation, and it is called vector. So vectors can be multiple dimensions to be precise, 80 or something like this. So suppose this is the vector that has been created for token 60, and similarly for every other token a vector is created. For 80 this can be this vector, for 90 another vector, and for 100 another vector. So this is what happens in the embedding layer. The tokens are converted into vectors. So let me give you a brief summary up to now. You have a sentence, I love deep learning. It has been converted into tokens, and the tokens are passed through embedding layer, where every token is again converted into another numerical representation with multiple dimension, and they are called vectors. So these are the vectors. So now after converting your tokens into vectors, they are passed through self-attention layer. So similarly, let me create another layer called self-attention layer, making it nice and big again. So in this layer, each word looks at every other word and decides how important they are to understand the meaning. For example, in our sentence, I love deep learning, deep may pay close attention to learning because they're strongly related. So let us understand what actually happens in the self-attention layer. So these vectors are passed through self-attention layer, and you can think self-attention layer as communication between these vectors. So these vectors communicate with each other to identify which words are strongly related to each other, or to understand context between the words. Again, let me give you an example. I will give you two set of sentence to understand about what happens in the self-attention layer. So suppose you have these two sentences. First sentence, she went to the bank to deposit her paycheck. And this second sentence is, they set up their tent on the grassy bank of the river. So in both of these sentences, the word bank has different meanings. So for example, in the first sentence, bank refers to maybe a financial institution. How do we know that? Because by reading the sentence and by looking at other words such as paycheck, we can guess that the bank word is referring to financial institution. Similarly, in this sentence, maybe bank is some piece of land at the side of the river. So how do we know that this bank and this bank are not the same? Because we looked at other words in the sentence. So similarly, your sentence is passed through self-attention layer, and in the self-attention layer, the context of the word is identified. So I hope you understand what happens in self-attention layer. Now, after passing your vectors through self-attention layer, these are further passed through multiple layers of transformer. So let me create another multiple layers. So suppose this is layer 1, this is layer 2, and this is third layer. The attention scores that has been generated in self-attention layer are processed through multiple transformation layers where the model learns deeper and deeper relationship between the words. So in self-attention layer, you have identified the context of the words, and you have identified you have identified which words are strongly related. But that is not enough. Maybe that process needs to be continued for multiple layers. So this process is carried out for this layer, again this layer, and again this layer. And in each layers, your model understands deeper and deeper relationship between the words. So finally, when each word is represented by a vector that contains meaning not just of the word but the context around it, this final output may help the model predict the best next word. So again, to summarize what happens in the transformer step, first you have a sentence, I love deep learning. The words in the sentence are converted into tokens, and again it goes through embedding layer. In embedding layer, your tokens are further converted into vectors. After passing your vectors through embedding layer, now they are passed to self-attention layer to understand the context and relationship between words in the sentence. And now this process is done through multiple layers to understand more deeper and deeper relationship between the words, and that is what happens in the transformer layer. So I hope you understand what happens in the transformer layer. And if you want to know more about what happens in the transformer layer, I highly recommend you to go to this site to read the document called Attention is All You Need. So search this in your search bar, and you will see a research paper. Yes, this is the research paper. So this research paper was published by Google, and you can read about transformer more and more here. So I highly recommend you to go through this research paper. I'll also link this in the description below. So now continuing on the video. Once you have understood about transformer, now, but how does it even know what words and patterns are important? Well, ChatGPT was trained on a massive amount of text, book, articles, websites, pretty much a large chunk of the internet. During training, it didn't memorize facts. Instead, it learned patterns, how language flows, what works, what words usually follow others, and how grammar works. For example, if you write peanut butter and, it's seen the phrase peanut butter and jelly so many times that it confidently predicts jelly as the next word. Now, after pre-training, there's one more important step: fine-tuning with human feedback. Once OpenAI has been showed different responses and asked humans to rank them, which reply was more helpful, more polite, and more accurate. This process is called reinforcement learning with human feedback, and it is also called RLHF. It teaches the model not just to generate words, but to generate words that are helpful and safe. And that is the reason why ChatGPT can refuse inappropriate requests or explain things in a polite way. It's not just smart, it's been taught to behave that way. So now let's talk about how ChatGPT replies. ChatGPT generates text one token at a time. It's like autocomplete, but supercharged. For example, if you say write a poem about stars, the model takes that, processes it, and thinks what's the best next token, then the next, and so on. It keeps going until it forms a full poem, not token, poem. So even though it feels like you're talking to a real person, it's actually doing rapid maths and probability behind the scenes, predicting the next best token over and over again. So let's go through a real example. Say you asked something like explain gravity like I'm 10. So what your model does, it converts that into tokens, passes it through a layer of attention, match it with patterns from its training, and then output something like gravity is the force that pulls things down, like when you say you drop your toy. It's not just retrieving from a database, understand that. It's generating that answer on the spot. So to sum it all, your message gets turned into tokens, passed through a transformation with attention layers, processed using patterns learned from massive data, refined by human feedback, and it generates a response one smart token at a time. It's not just magic, it's deep math, deep learning, and smart design. If this video helps you, then please don't forget to like, share it with your curious friend, and don't forget to subscribe for more visual tech breakdowns like this. Thank you.